So in this unit, we're going to introduce what's called coordinate geometry. So we're going to start today by establishing a couple formulas that we like. We're going to be finding the lengths of segments, their slopes, and their midpoints as well. So we'll start by finding the distance between points. You may want to grab a piece of graph paper. If you haven't done so, please do. So suppose we want to find the distance between these 2 points. Well, of course, you're going to draw your x and y axis. You're going to go down to -9, -6, which looks like it's right about here. You're going to go over to where 3, 10 is. You'll do a much better job than I will because you'll have a ruler and I don't. So you're going to draw that segment in there. And now we want to find the distance between those points. So you might be thinking, well, let me just use my ruler and I'll measure it. But hold on a second. Because what if we have different size graph paper? Suppose that the squares on your graph paper are different than the squares on mine. We're going to get a bunch of different lengths. So how do we establish consistency? Well, here's what we might think about doing. It's hard for me to count boxes going up this way here. It's really tough for me to do that because I don't know how far a box is if I'm going diagonally. So that's going to be tough to do. But I can go horizontally and I can go vertically. So notice at this point here, which makes a right angle with the 2 other points, it looks like it's at the coordinates 3, -6. So let's talk about how to find the distance horizontally. We could count the boxes, but also realize that what you're doing is you're saying, what's the vertical change? If I do 3 subtract -9 or 12, my distance is 12. Likewise, if I go 10 subtract -6, my distance between the points is 16. So now if I do some Pythagorean theorem, I can take 3 minus -9 and square it. And then 10 subtract -6. Square that. I'll squeak some parentheses in there too. And let's say that's equal to the square of some distance. There's a Pythagorean theorem. So if we simplify this down a little bit, we're going to get 12 squared plus 16 squared equals the square of some distance. 12 squared is 144, 16 squared is 256. Their sum is 400. And then if we take the square root of both sides to undo, we're going to get that d equals 20. So the distance there is 20. And that's good because it's 20 units, where each unit is the width of one box on my grid. So this way, no matter what size grid you have, it's going to be 20 units long. So can we generalize that a little bit? Think about what we just did. Let's say we take 2 points, like x1, y1, and some other point, x2, y2. And we want to find the distance between those points. Well, if you think back to what we did here, didn't we find the difference between them, the change in the values? So if we do the same idea here, if we find the change in the x values, that's going to be one side of a triangle that we can then square. And likewise, if we find the change in the y values and square that value, that's going to be the square of our distance, the Pythagorean theorem. Now, to be honest with you, we don't really like our equations equaling to something squared. We like to solve for the variable we want. So if we want to solve for d, we'll take the square root of both sides. So the square root of d squared becomes d. And on the other side, we get a big old square root with the sum of the squares of the differences of the coordinates. How about that? If you think about it, it's the sum of the squares of the differences of the coordinates. We call that the distance formula. It's really just a glorified Pythagorean theorem. But it allows you to maybe not use graph paper if you don't necessarily want to. Let's practice one of these. Use your distance formula and determine the distance between these 2 points. So if I do my distance formula, maybe I call this one x1 and y1, and that's x2 and y2. It doesn't really matter because we're squaring it anyway, so it doesn't matter what order we subtract in. So my distance then, here's my square root, the difference of the x's, 2 minus -3, difference of the y's. So when I do these out, let's see what we get. We're going to get the square root of, this is the square of -5, another square of -5. -5 squared is 25. So this gives me the square root of 25. Holy square roots. Sorry about that. And when we add those numbers underneath the square roots, we get the square root of 50. Now, do you remember simplifying the square root of 50? So if we're going to simplify the square root of 50, I'm going to take two numbers that I know that multiply to 50, but I want one to be a perfect square. So let's rewrite this as the square root of 25 and the square root of 2. And then the square root of 25 is 5. So our distance in simplest radical form, which is the preferred way to write a radical, 5 radical 2. If you can get it down in that form, that's great. And I think you simplified the radical last year when you were solving quadratic equations. So that's a good example of using our distance formula. Let's keep going a little bit. So let's see, what number is halfway between 4 and 12? I know you can probably count up, but let's think about why that's true. The number in the middle is the average. It's like the median. So if we add them up and divide by 2, that's going to give us the number in the middle, 8. Moving on now a little bit. Let's do the other one. Same idea. And the average of those two numbers is -1. So why do we do that? Because we want to put it together now and find a coordinate. Now we're going to be on a grid maybe. If you want to graph these 2 points and find the point that's halfway between them, we could do that because we want to know what's halfway between 4 and 12. So its coordinates is going to be the average of 4 and 12 and also the average of -7 and 5. So the point that's halfway between it is 8, -1. Take a minute maybe and graph it. Graph the two end points, graph the midpoint, and check it out. So that motivates another formula. We're going to generalize again. We have those points x1, y1. We have the other point x2, y2. So then the midpoint formula, what do? You add them up and you divide by 2. Oh, wow, that's an awesome saying. I learned that saying in 9th grade too. That midpoint formula, what do? Add them up and divide by 2. We were trying to remember all these formulas, and a girl in my class, her name was Jennifer Castaldo. She said, midpoint formula, what do? You add them up and divide by 2. And we all thought she was like the greatest person in the world. So who knows where she is now, but we recognize her and her contributions to math. Now, more importantly, do you notice that the midpoint divides the segment into a 1-to-1 ratio? Remember we did centroid before that was a 2-to-1 ratio where one part was twice as big as the other, or one piece was half the other one? Notice now that the midpoint divides it into a 1-to-1 ratio where both pieces are congruent. Just wanted to kind of clarify that because I know something that's coming down the road and you're going to have to handle it. All right, so we got distance, we got midpoint. The last one's the easy one, my friends. Do you remember how to find slope? I think we talked about it in class a couple days ago. Slope was the change in y divided by the change in x. Do you know why we use the letter m for slope? We use m because the Greeks used to call the slope the measure of a line. They measured its steepness. So if we want to figure out the slope between these 2 points, let's do the change in y's. Now in this case, it matters what order we do them in. So if I'm going from 8 to -4, I'm calling this one y2 and this one y1. So I got to be consistent and call that one x2 and that one x1. So then I'll do negative 16 subtract negative 3. So let's see, 8 subtract negative 4 is like 8 plus 4, which is 12. And negative 16 subtract negative 3 is like negative 16 plus 3, which is negative 13. How's that look? My arithmetic good? So we start off with the challenging one, the distance formula. We kind of slimmed it down a little bit to the midpoint formula, and then we recognize what slope is. Exactly. And two last things that we're going to be using. The slopes of parallel lines are... Yes, the slopes of parallel lines are equal to each other. And the slopes of the perpendicular lines are... Yeah, we call them those opposite. Or we say they're the negative reciprocals. Cool. And remember, the reciprocals is when you flip a fraction over, and the opposite reciprocal is when you change the sign. So this is this foundational stuff. Just a couple formulas, a couple concepts to understand. When we have these nailed down, hopefully by our next lesson, then we can actually do some really good stuff with these formulas.